And we're going to record, right, Zach?
Yes, I just started the recording. And let's just go for it. It looks like there's a few people coming in, but we're going to get through some of the introductory slides and take care of the housekeeping. But again, welcome everybody. This is Zach Parnell, Vice President of ITI. You're here for an ITI Showcase Webinar, which is these are, well, I guess I have a vested interest on part of them, but I really think these are awesome. There's a ton of good information here, and we're excited to have you. So our host again today is Mike Parnell. He's our President and CEO of ITI. He'll be talking about rigging and sling failures, case studies, and solutions. What's really neat about this, before I get into it, I want to give you a little bit of background about ITI. ITI actually started as wire rope and rigging consultants, and today, and that was because of Mike's background in wire rope and rigging. Today, we're a world leader in crane rigging training. We have companies in Canada and the U.S. and Brazil, and we're growing into the Eastern Hemisphere as well. A lot of different industries obviously conduct crane rigging activities, and I think there's about 200 folks that registered for this webinar, and coming from all these different organizational industries, and from defense and aerospace and shipbuilding and wind and power gen. So welcome everybody. And a lot of you are obviously customers of ours or other locations of your company or customers, but if you're not a customer, this is your first time getting to know ITI, we really welcome you and are excited to kind of give you an idea of what we're all about. So, and this is what I did want to go to our website really quick, everybody. This kind of goes over, the Showcase Webinar Series is a free monthly series that we do. So this is a big list of past presentations, and then we do webinar training courses as well, in addition to obviously our client site training and training centers that we have throughout North America. But I get a lot of emails at the end of, about a week after every presentation, how do I access the past presentations? So I want to hop over to my browser really quick. I'm at iti.com, this is our website, and at any time you can actually go right to this homepage and click webinars, and it'll take you to a page that has our Showcase webinar upcomings and then our webinar training courses. If you click into Showcase webinars, there's a button here that says View Past Recordings. So and also you can obviously see the upcoming webinars. So this month, this is the current webinar. Next month, we have Joe Collins coming on from Becht Engineering to do a crane accident, managing crane accident webinar. But yeah, if you click the View Past Recordings, you can always access, by filling out this form, you'll always be able to access all of the past recordings and the PowerPoint presentation. So actually the file that Mike's going to be going through today, along with all the past presentations, you'll be able to access there. So it's a just awesome amount of information. Really want to make sure everyone can take advantage of it. So let's get into the presentation. I'm excited that Mike, the joke works well when we're together meeting someone face-to-face. We say that he's my brother, but he's actually my father. He's the president and CEO of our company. And what's neat about his background in rigging and wire rope is obviously a lot of experience, but currently he's the vice chairman of ASME B30, which is the standard setting committee in the U.S. for cranes and rigging. And on that, he's actually the subcommittee chairman for B30.9, which is many of you know as slings. So he does a lot of accident investigations and expert witness testimony and whatnot, and that's why I think he chose this subject this month to go into, because he's done a great deal of research and accident investigation on this. So I'm going to change the presenter over to Mike, and the last thing I'd like to say, Mike, before we get going is, if you guys, attendees, if you have any questions, be sure to put them in the question box, and I will be filtering them and passing them along to Mike, probably to answer at the end of the presentation. So, Mike, we can see your screen, so take it away.
All right, welcome everybody. We're very glad you're here with us. This is a fairly packed webinar this morning or this evening, wherever you are. I know we have generally we have Richard joining us from the Netherlands and lots of folks from India and Africa, Brazil, Singapore. So wherever the day is or time of day or night, we're very glad you're with us. This is really a short study on rigging failures and sling accidents. And I wanted to, let me dive off into the presentation very quickly. There are some case studies that we've done. We just pulled up 60 different accidents that we had on file over a 25-year period. And you can see that we have a pretty good cross cut here, right in this area from left and right. You'll notice that there most of these are sling related or hardware related, and then this group is wire rope failures and or crane and rigging procedures. And so we started to continue to evaluate that a little further and segregated it just down to slings. And out of those 60, we had 23 sling accident investigations. And of that, I think the surprising element is 87% of those accidents involve synthetic slings of some type. And that would be, that grouping, of course, is web slings, round slings, or synthetic rope slings. The predominant type of material would be web slings and round slings. We do have a few synthetic rope slings in the review, but let's take a look at of the mode of failure for these slings between the 4 different categories that we had initially highlighted. Synthetic slings, of course, here, then chain slings, wire rope slings, and then rigging hardware. You can see that out of all of that, we would call or typically identify that for abuse. That would be field issues that we might, as users, incur onto the sling or rigging. And then one category right here, we've had a couple of incidents where we've had fabrication issues, and that has to do with wire rope slings. And those were actually both related to the use of wire rope clips or cable clamps. And we had 2 fatalities related to that. And so that's building our own slings for some reason in the field, using cable clamps, hoisting up. And then as the rope, that's the part of the issue is when somebody builds a sling using cable clamps. I'll just draw a short one here and put in some clips. Of course, the saddles go to the live side. And when someone builds a sling like that for some particular purpose, it's not really advised. As the load is applied and we carry pick that load up, as you all know, wire rope reduces in diameter slightly as it gains tension. So that slight reduction in diameter reflects the ability for those cable clamps to actually hold. And they are torqued, but over time, that reduction can affect the ability for that clamp to hold. And that's why Crosby and CM and others encourage us to retorque those after taking initial load. But at the end of the day, what occurred in both of these circumstances was that after the clips were applied, the rope slipped through the clips and dropped the load. So really terrible circumstances and results out of that. But there's a huge reason not to be building slings in the field, and this gives us good food for thought as to why not to do that. Let's go on to our case studies here. Case number 1 was involving a large steel ring, which I'll show you in a minute. There were a couple of abrasion wear pads on this ring. This was in a machine shop, so it was being milled on one surface. The idea was to stand the ring up vertically with an overhead crane, so stand it up in a vertical position and then rotate it 180 degrees and then lay it back down. So they wanted to mill the other side. So they were standing it up on an uneven floor surface. The result of this was an amputee. It started at the foot, went to ankle, went to knee, and then went to thigh over time because of continuing medical issues. And this thing was settled out of court. But I want to show you this is the ring in question. You can see, and it's about 11 feet across or so. but you can see the brilliance of the steel right there on the inside race or run, and it had been cut on the inside. That's a casting, and that was cut on the inside on a milling machine basically a lathe, and this edge right here was sharp on the top and on the bottom. So as the sling went around that edge to pick it up, this was in effect choked and picked up to upright. The result was walking right through the synthetic material of the protector and the synthetic sling. And you'll notice this portion right here connects right over to the sling portion that's failed right there, and then initially that also started to cut the second layer. So we had completely through first layer and then started through the second layer, and once the first layer blew up, it dropped the load. The ring fell over onto the gentleman operating and got his foot, and the rest is history. You can see that when we would do an accident investigation like this, the end of this sling was very fuzzy, and it really indicates cutting versus a sliding friction failure. So it was literally just a shear and dropped the load, and we ended up with a pretty good lawsuit out of it, and it all got settled at the end of the day, but it was something very avoidable. And part of this really leads to further discussions later on in the webinar about sling protection. Let's take a look at case number 2. This involved a mini excavator and about almost 6,000 pounds. They had 3 slings that were involved: an older sling that had some UV damage and had been previously cut in a couple of places. I'll show you that. And then 2 new slings. It was actually a triple sling failure, very unusual, but it did. It dropped the whole unit, and pretty good cost. And as a result, 9 folks were given the day off as a result of no planning. So let's take a look. The way this thing was rigged was round. This house was turned around, so the arm was up over on the other side, as opposed to this sort of a glamour shot for this machine. So the blade was back here, so we had 2 slings, one rigged here, one rigged off the blade there with shackles, and then a third leg was rigged off the boom up, and that's how it was picked. So this was the older sling that had UV damage to it, and I'll show you that in just a minute. And these 2 other slings were brand new out of the box and had not seen a load yet. So let's take a look at those slings. Now, but before we do that, notice, if you're really going to get a sense of what's happening here, the distance, the center of gravity of this, of course, there's a bit of a bottom weight and so on, but we estimated by the time this sling was up, we had about 70% of the load was actually allocated to that green sling. So we had substantial load to the most damaged sling, and we had then the balance, the other 30% was split between these other 2 slings here. So let's take a look then at the result. This ended up dropping 60 feet. No injuries, fortunately, for this one. Ended up upside down. You can see the blade is back here. And so there were 2 slings connected to that, and 1 sling was connected right here to the boom, to the digging arm. So on the first sling, the older sling, notice the discoloration and the condition of that sling. Very bleached, very faded. It was yellow originally when it was made new. And notice that the type and location of that failure was right in here. And notice how straight edge that is. I think I have a better picture of that on the next frame. So that straight edge, and there was another damage point almost uniform to that, and they were 6 inches apart. And we asked at the job site, they had some fairly oversized telehandlers on the job site that had 6-inch forks. And it looked like to us that this sling had experienced significant damage prior to. This is really kind of a two-step failure. Well, three steps really, and I'll go over those very quickly. And that has to do with, one, that we had a loss of strength because of UV ray degradation. And we are in the about 50% range based on the age and the discoloration of this sling. So when we first we have loss of strength, total strength. Second, we had prior damage, and that is the result of these cuts that were on the inside near the wear pad inside of the bearing point of the eye. So we have inside cuts and outside UV damage, and then we had a slight overload condition. It's one of those perfect storm of events that show up all collected at one moment in time, because they ended up with 70% of the load on that one sling, and they had only anticipated about 50%. Wasn't a lot for the sling. You know, it needed to stay within its rated capacity. However, they did exceed that. But in the doing of that, they also were fighting prior damage and loss of tensile strength. So when we also overload it, we ended up blowing up the sling. That caused the first failure. So I'll go back a couple of frames here. So this sling failed first, and it allowed the excavator to actually rotate over 180. As the excavator rotated over 180, these two remaining slings held on for dear life. And you can imagine that I'll just put a couple of put a shackle here for you. And there's some fancy fourth grade artwork for you. So the slings were holding like this, and as the excavator rotated over, the pad eye or lug that was containing that shackle completely rotated, and it pulled the shackle and rotated the shackle actually inside of the sling eye. So we have a loaded sling, dynamically loaded, and the shackle is now hard up against the edge of the blade, and then it's rotating, and it's steel turning inside of a sling eye. And so as a result of that, let me take you to those slings now. Here's one. It was literally highly fused, fairly hard, friction damage, and then a tearing of that sling, melting and tearing of that sling eye, and that's the rupture in the end of the eye. And you can see on this one, and I'll go to the next one. Here's the other one. Here's the brother to that. See all of the fused melted fibers right in here at the separation point, and we were able to pick that up basically microscopically, all these fused fibers in here from heat damage. So it's real glassy looking, hard plastic looking, and certainly should be soft synthetic fibers. And in this event, they were very, very hard and very fused, and we knew that most of the separation was caused from the quick heating condition, causing that sling really to melt in two at the end. So dropping the excavator, very, very avoidable. The first sling was the initiator, and the second two slings simply paid the price for that. Let's take a look at the third case. This was a large beam, and it was very tall. They were actually erecting or assembling this beam for an HVAC unit on the top of a hotel, and using a helicopter to place this beam with. And the slings were used in a choker hitch around the beam, two of them, and I'll just throw in a couple of choker hitches here. And the helicopter pilot did look at those. It was the beam was about. I'll show you the beam height in just a second. These two slings did not have any protection on them. Helicopters, of course, provide some vibration and dynamics, and they ended up with $40,000 worth of damage as this beam upended and went straight down through the penthouse roof on the hotel. It was a large a 30-plus story hotel in downtown Seattle, so they ended up with a skylight that they really didn't plan on, but it was a lot of damage. Take a look at the slings that were in question. They actually sewed the sling, put an eye back up here in the main body section, and re-pulled these to destruction to try to confirm their original integrity. And they pulled at 98 and 100% of original tensile strength. So they were fine for muscle and strength. And slight 2% loss based on load handling. But they actually proved out the slings were just fine. Notice that this, if you can see the amplification here, first set of cuts were at the 11-inch mark from the end of the eye, another set of cuts at the 33-inch mark, and then another set of cuts at the 44-inch mark, and a final set at 66-inch. So the beam was really 22 inches tall and 11 inches wide and 22 inches tall. It gives you a perfect layout of how these two slings were rigged and where the failures occurred. You can tell pretty well where the primary failure was, very clean, fairly square edged. Take a look right here, very, very straight edge surface, and there was a first failure point. And then as the beam upended, started to turn, you'll notice you've got a curve right here a bit. As the beam starts to go invert and down in through the roof, the turn in the sling reflects the curve or the turning axis or the turning orientation of the beam, and there's the second failure. And this one had friction damage to it as well as cutting. This one appeared to have just more cutting first as its mode of failure. But it was very distinct in the lines of separation. Here's another set of severe cuts and abrasion right there where they were rigged. So you can see very, very symbolic of the event. When folks ask me, gee, how did you think this accident occurred, and they send me a bunch of pictures and this and that, and eventually I've just got to get my hands on the rigging or on the equipment that's failed. But the evidence almost tell you always how did I come apart? How did I fail? How did I drop the load? The evidence really will speak for itself. And having and retaining that evidence is very, very important. I think we'll end up doing a workshop after Joe Collins this summer or fall on accident investigations for rigging, and the need for retaining that evidence, keeping it in custody and unaffected by anyone doing any destructive work with it or anything else. This is a very good example of capturing that evidence early on and then being able to lay it out and let it tell its own story. Let's take a look then. Case 4. We have, this was a 19,000-pound paper mill machine. It was a smaller machine, but it was large. It was in a crate, and it had hard points about which to basket. But the size and shape of this required that two boom trucks were used side by side to rig this up. And so I'll just kind of give you a quick sketch here. So they had hard points here on the crate, and both of these went up to boom truck hooks. This was a fairly good span. They didn't have a spreader bar. They opted to use two boom trucks side by side to pick it straight up and off the trailer that delivered it. And the crane hooks, our evidence showed that we had some damage in the hook bowls, which I'll exemplify here in just a minute for you. Dropped the load on one end. This whole load came down on one end, crashed, did a lot of damage to the machine inside, obviously broke up all of the crating, and they simply had to load it back on the truck and send it back to the original manufacturer for rebuild. It was a very expensive adventure and something that could have been sidestepped very quickly. 4 months replacement time, a lot of lost revenue out of this thing, and very avoidable. I'll show you the sling involved here, the one predominant sling. Notice this one. This is actually a kind of a silver-colored or gray-colored sling. It's not a UV damaged sling. This is its actual coloration, and that was fine. We checked that out. But notice where the eye is separated. This is the sling eye at one end, and and if you actually tape this out, you can see that the tape measure is right here at the midpoint, and about 1 inch to each side of that are cut points. This one was certainly fatal to the sling, and this was supplementary. But when we fold this piece back over, it matches up with the separation of the basically the balance of that tapered eye section. And where this really got into a bind, I called the construction company who was involved in this that was helping during the outage, and I had asked the question. I'll just kind of try to do a little bit of more of a three-dimensional configuration here. Of course, this was in a swivel, and the hook latch was right here, but the block was here. And so really I asked the guy, I said, what was the condition of the hook bowl? And he said, you know, the sling eyes both went into the hook bowl, and he said, we went out and looked at it. I just got back in my office. Thanks for calling. But the grinding you hear in the background is them dressing the hook up. And what the issue was is these hooks are sometimes what you might say is concave. They have a bit of a hump in them. They're a bit rounded. But over continued use with spreader bars, lifting beams, chain slings, and wire rope slings, it peens that material out into something of a flat saddle and creates very sharp edges right out here on the perimeter on both sides. And this hook is about 2 inches wide, and so it ended up that we had 2 razors on the outside edge of each portion of that hook bowl, and those are exactly where the sling eye was bearing to. And the sling eye in question went up, across, and back down, and was the victim of these 2 sharp edges on the hook bowl. And so if you have cranes in your facility, take a look at the hooks and the condition of the hooks. If we're using a lot of spreader bars, lifting beams, chain slings, wire rope slings, they'll all do scarring and peening in this hook bowl. You really want to take that into consideration when we add then. Now we're going to drop in a synthetic sling of some type, and it just isn't going to be happy. You know, certainly a case here is a great opportunity here to put in a rigging shackle as the carrier for the slings, and rig from the rigging shackle and rig from down here, and let that shackle pin sit up in the hook, and take that be the interface between that roughed up steel, and make sure that this is all clean and nice and friendly to that sling down there in the hook or the shackle contact area. So rough hooks will get you every time. I mean, it's one of those. We look at ours very regularly to make sure we've got a good interface between our synthetic rigging and our hardware connection. Hardware can be shackles, master links, or hooks. So just something to keep in mind. You know, it's always about lessons learned from other folks, and these are things we sure want to avoid. Knowing these in advance is a great way to get around and avoid having an accident. Certainly you want to dress the hook. There is an allowable for metal loss. You can check ASME B30.10 for hooks and get guidance there, and certainly check with the original manufacturer for their minimum or maximum allowable metal loss. So if you hand file or deburr those hook areas, make sure we don't exceed that maximum metal loss allowable for those particular hooks. So, and I would very strongly encourage you not to grab a high-speed grinder and start grinding on hooks. A great way to induce heat and actually to continue to add some burring. So there's a particular filing system or filing method that you want to impose while you're doing any dressing for the hooks. So be very cautious and use the manufacturer's recommended method for dressing the hooks out. Let's take a look at the next one. This is case 5. This is a large steel 23,000-pound box beam, and this was in a this was a disassembled crane, and these are the gantry legs for this crane, large box beams. They were basketing using 2 synthetic slings, and we ended up, this was a fatality. We ended up losing a gentleman over this, and the slings slid along the surface, and they were using abrasion wear pads. So let's take a look at this. And between case 5 and 6, Zach, I'm going to ask that you run our first poll about those that have experienced a rigging accident. So just be ready for that just as soon as I finish this one and get to the next one. So this is a view of that sling laid out on the table. Right here, you'll see a couple of folks that are from an OSHA, one of the state OSHAs that asked us to do some of this evaluation. They were there to witness the evaluation, and we found numerous locations along the sling. You can see all these A2, A1, A2, A3, A4. These were, in some cases, ongoing or existing prior damage type conditions on the sling, in addition to the real primary failure points, which I'll show you in just a minute. So this sling really had seen a lot of service. It had a lot of abrasion already on it. You'll see some degradation based on UV condition, some small nicks, small cuts. Let's take a look, a little closer look. This is a very, very good example. There are 2 things happening here simultaneously. One, notice how plasticized those ends of the webbing are in their profile. All of this material was very hard to the touch, very brittle, you might say, or very, very tough, plasticized from heat, friction, sliding action, and really notice how kind of square-ended those are as well. That the angle wasn't all that great. It wasn't a huge flat angle that would really initiate this sliding action. We found out that the beams were wet and they were greasy also, but certainly a method for rigging this might have been spreader bars to help spread those slings out and get them more perpendicular. But we did have an angle there. It was about 70 degrees or so. But notice the other thing. So we had a sliding condition that created the friction, and the second thing is notice how narrow the slings are. So there is a condition here. We had very high PSI. These were 4-ply slings. We had 1, 2, 3, 4 layers of webbing. And so to get the strength that you need, these were high-capacity slings, but they were 4 plies in their thickness. And it may have been a little better, though friction was the real culprit, when we really talk about, gee, if these slings, instead of being 3 inches wide, were 6 inches wide, that PSI would have dropped dramatically over the width of that sling. And I think that a contributor here in my personal analysis was that the narrowness of the sling caused a high pressure, and as the sliding occurred, it was focused on on a very restricted width of sling. And if we had a wider sling, certainly with better sling protection, we might not have dropped. They might not have dropped the load. But I do believe that the narrowness of the sling contributed to this overall accident. And that's why on boat slings they're wide. They're 9 to 10 to 12 inches wide. Help spread the load over a broad surface, lower the PSI, lower the crushing ability to the load. It all has some influence. But take a look down the sling body. We had, you can see the plasticizing or the thermal damage there to the sling. And then we had some fuzziness with some cutting, but all of this was very, very hard to the finger, to the touch. You'll see then these are sympathetic cuts that were, as the sling slid, it failed at one point, but nearly was able to penetrate the other portions of the sling. Really important to understand here, this was the most shocking part of this particular accident that led to the fatality. They were using abrasion wear pads instead of sling cut protection wear pads. These are very suitable for the right application. But these are 8-inch wide, 12-inch long, 6-inch wide, 12-inch long pieces of webbing. They're sewn down one side.Ese are all commercially purchasable. They're sewn down one side. They enclose with a Velcro enclosure. But notice the ability of that sling with the heat generated. I dropped this on my shop floor during the investigation on purpose, and this thing thumped. It hit like a rock. And this entire surface right in here was very, very rigid and solid from the thermal damage, heat damage. And you can see that the interaction between the sling that had basically ended up penetrating right here, and its contact area on the corner, and we had a sling failure right there. But that whole surrounding area, the wear pad and sling slid as a combined unit and melted the wear pad, in addition to causing the sling to fail. Notice on the off side over here, we had an entirely separate wear pad that also experienced that very harsh heat damage. So we've got a good thought, a good idea about using sling protection, but these really are for abrasion, like might be used with wood, or maybe possibly with concrete, where you have a rounded edge. You want to protect the sling from abrasion damage, but there's really no hard edge for the sling to fail on, and you want to make sure that the sling doesn't run. So in this case, these are abrasion okay, but not for cutting. And that is, we want to get very sophisticated about what sling protection we're using with the particular slings in the application that we're using them for. Let's take a look. This was our overall analysis of the sling failure mode. One sling slipped, causing the initial failure. The beam went downhill on this side. It landed down, and this sling then had no choice. It slid uphill, causing the second failure. So we had a double sling failure. This unit eventually tumbled forward off of a large cribbing stand and fell onto the rigger on the ground that was giving signals. So the gentleman was standing right here in front and ended up as the victim in this case. So the sling angle wasn't very high. It was a very large, tall angle from horizontal, but being wet, being oily and greasy, slings can slide. So you just want to bank on. Here's a case, and I'll just draw this in here. Here's a great case for a spreader bar going up and then using perpendicular slings right off that bar to encourage straight vertical leg loading right here, and lowering the option or potential for sling movement along the surface of the beam. Certainly, we still would have been obligated to improve the protection between the sling and the load surface. So that still was an issue personally for me. I mean, my gosh, the load's 23,000 pounds, so the PSI is very, very large on those sling contact points. So we needed better sling protection in there to hold that sling off of the load. All right, Zach, you want to do, I'd like to ask, there's a poll, initial poll. We have 3 of these this morning or today, and if you can do that, I'd appreciate it. Let's run that poll right now, and then we'll give people 20, 30 seconds or whatever, and then see what our results are.
Yep, it's up on the screen right now. The question, everybody, is yes. Well, it's not really a question, but a statement. Yes, my organization has experienced a rigging accident within the last blank month. So let us know if that's 3, 12, 24, 36 months or none that you know of. And Mike, I might ask that you help define what a rigging accident might be for everybody.
Okay, and I think in this case it's really anything from the crane hook down. If it's a mobile crane or overhead crane, it's really not related to tipping a crane over or having an overhead crane come off the runways. It could also be chain falls, drifting a load inside of a structure, inside of a ship or an engine room. So a rigging accident can also be where we actually are leveling the load with chain falls, or maybe in some cases come-alongs. But particularly it's about the interaction between the sling or slings and the load, maybe a loss of load by load tumbling out by basket hitches or choker hitches. We might have had a failed hoist string or an eye bolt. Could have had a failed failed rigging hardware component of some other type. So I'm really focusing, that question really focuses from the hook down, not really particularly from the hoisting mechanism, but from the sling and hardware connections that were used to employ the load lift as a whole. So that's really the focus of that question. Let me know when you're done with your poll, and I'll go on with our last case study.
Yep, we got about 72% voted, so folks will wrap it up here in about 5 seconds. I assume, Mike, it would have to do with obviously any catastrophic accidents, but also even dropped loads where no one was hurt.
Yep.
Is that
right, yeah, absolutely. Yeah, because it's whether it's load damage, injury, or fatality, at the end of the day, it's an unplanned event and something that probably was avoidable. So that's really the focus point.
Okay, great. I'm going to close the poll. We have 74% voted, pretty good. And I'll share it here on the screen. I'm not sure if you can see this, Mike, but it looks like we have 16% of the people have said that their organization has had an accident in the last 3 months. And then about 14% in the last 12 months, 5% in the last 2 years, 3% in the last 3 years, and 63% said none that I know of. Okay.
So really, I'm taking away from that 37% of the attendees have had some experience with a rigging accident in the last 3 years. Is that fair to say, Zach?
Yep, exactly.
Okay.
So I'll hide it down.
All right.
You'll have your screen back.
Okay. All right. Yeah. So there's a lot of avoidable incidents. To have more than a third of our folks that are attending, this is a great reason to be participating today in this and encouraging others to get better at sling protection and better rigging methods. And that's part of why we're having our discussion this morning. So thanks everybody for taking that poll. We have another one coming up, Zach, I think in 4 or 5 frames here, so we'll be ready for that one. Let's take a look at the 6th case. This is a tower crane jumping incident that we're involved in. I won't use the name of those. This was 7 deaths in this particular one. But let's just take a look at the issues that are currently evident. And these were 4 of these slings were used. These were very short slings, actually, only I think 4 foot or 6 foot in total length, maybe 6 foot. And take a look at some of the failure points there. And I'll get a close-up shot of one of them. But I'll tell you what, without any sling protection, if an edge is able to actually cut the tag that cleanly, I think that's the most remarkable part of this, is that we've got damage right in here. And notice how sharp that was able to separate that tag in addition to the fibers below it. And to my knowledge, there are no evidence elements of heat damage. This was all just pure cutting and shearing these 4 slings that ended up dropping 3 large collars that allowed the tower crane to actually fall over. So just note how you could have taken large shears to cut sling material or leather and just done the same amount of damage as we did here with the load contact point. Very avoidable, and this is something that can happen in a fairly strong angle right there. So it was, we were able to actually piece back together all 4 slings. We were able to mate them back up, all fuzzy, no friction damage, all sharp cuts, and we paid a significantly terrible price for it as an industry. Okay, so let's take a look. Zach, can you run the second poll for us, please? And so this really will get down to the slings involved in a typical rigging accident. So out of the 37% that might have been involved in an accident in the last 36 months, let's get a kind of a percentage understanding of what sling type was involved in those accidents from what your experience is. You noticed our experience was 87% were synthetic related. What's your experience, and what percentage or what count can we derive from that?
Yeah, so the question up, everybody, if you have had a sling accident of any type, and just to clarify, it could be a near miss, dropped load, not even a fatality or injury, but what slings were involved in a typical rigging accident: wire rope slings, web slings, round slings, or chain slings. And we have about 37% have voted. So it looks like we're going to be right around that 40% number if that many folks had accidents.
Okay.
So I'll leave the poll open here for another 5 seconds or so, and then show the results. I don't expect many more votes. So.
And the synthetic slings would have been in the web sling and round sling. We would combine those two.
Yeah. Yeah. So I'm going to close the poll now and share it. Yeah. And wire rope slings and chain slings only account for 19%. So web slings and round slings account for about 81% in this poll.
Isn't that phenomenal? Isn't that amazing? And I'm going to put my screen up, Zach, or you can get me back up here. Our evidence in 60 cases over a 25-year period, our particular company, or just our little company, I'll just say that, we have 30 people here working with us, and in our experience of the cases we've actually managed to help clients resolve, 87% were synthetic related. And what I think, and what was the percentage that combined between web slings and round slings on the poll you just finished?
81.
I think it was 81%. Isn't that interesting? That just really, asking the general using industry, your experience is very close to our experience. This is a huge, huge issue, and we really want to start, paying more attention to it as a group. Synthetic slings are continuing to gain in popularity and usage. I know a lot of folks are changing out from large braided wire rope slings to large synthetic round slings, as well as large synthetic rope slings. And when we start imposing or using synthetic slings into what was old school steel slings, we're going to continue to, I think, run the risk of doing damage to those slings if we don't mate them properly to the hardware. And I think so. A couple things I take away from this is, are we mating it properly to the hardware? And that's really a big question. That we do get some issues related to that. Are we protecting against the edges? And it doesn't have to be. We don't really have to use the word sharp edge. It's just an edge. And are we protecting it against edges? Because a lot of times we'll use choker hitches and basket hitches as our rigging method of choice, and we've got sling contacting right to those edges, and we've got to hold those slings off of those edges while they're under tension. And that takes some robust material to do that. And an old web sling or a piece of fire hose will not do that. No, an old leather glove will not do that. So we'll cover that a little more in depth here in just a minute on an extended part of our webinar. Great answers on that. Your percentages are very, very close to ours in our experience. So points to remember are if synthetic slings are being used, is there protection in place? Inspecting the crane hooks and shackles for rough surfaces. And consider a clean rigging shackle or master link assembly to avoid bunching of slings and to ensure smooth connections. Let's take a look. I just threw in 3 or 4 slides here to help us out, but typical rigging method on a crane hook. Notice that maximum really recommended is 45 degrees from horizontal or 90 degrees full included. We don't want to get out to some excessive angles that will add tip loading potential, and certainly these hooks need to be clean surface. So 2-inch flat web and round slings, they just fit and just make that angle work, but make sure that we inspect that hook for its condition and how it's going to treat that sling material. Let's take a look here then. We've put 4 slings on the hook just for an example, and notice that we've now exceeded that from most extreme to most extreme. If we really had this in perspective, we're really at about 35 degrees here or so, and we're really crowding that sling up on that hook. A good solution, we don't want to overcrowd that and also get flat rigged. So sometimes what we can do is drop in, and we use a lot of these in our facilities in Memphis and Woodland both, is to use a master link at the top, sub-assembly coming off of that, and then whatever our slings need to rig off of there would help step that off the hook and also give us some hinging and adjustability. These hinging points right here and here help float out the tensions to a 4-way a lot better than just going straight to the hook. So you know that often when we rig up 2 legs to take load, or 4 slings to take the load, sometimes only 2 slings carry. So the more hinge points we add into the system, sometimes that will float that out to make it a 3 carrying out of 4, or sometimes 4 carrying out of 4, depending on the adjustability of that hardware. So it's very good. And one point of information, you'll notice right down here on the bottom, you can see right in this area, down towards the bottom, we've got a tag that's attached to that master link. And on that tag, it states the rated capacity for the large master link and also the rated capacity for the sublinks. So anybody picking up that hardware knows what the rating is for those links in series right there, and there's no guesswork involved. So always make sure, because master links, according to ASME, I'll just write this up here, ASME B30.26 is rigging hardware. Master links are in that rigging hardware document, as well as shackles, dynamometers, swivel hoist rings, eye bolts, turnbuckles, wedge sockets, and cable clamps. All those links, rings, and swivels are all included in that hardware volume. And in that, there is no requirement that these master links be marked for rated capacity. They need to be detailed out on a spec sheet or a cut sheet from the manufacturer's product catalog, but they get used in wire rope sling assembly, web sling assembly, chain sling assembly. So what happens is they're depending on these master links being incorporated into those sling types, and they let the tag on that sling assembly represent its rated capacity. So in this case, we might have this particular master link assembly that you see in front of you. It could be used for a 4-way wire rope sling assembly that's worth 24,000 pounds rated capacity. It could be used for a four-leg alloy chain sling that might be worth 21,500, and a 4-leg web sling that might be worth 20,000. So in all those cases, they're going to let that tag represent the entire assembly's capability. They won't. That's why the manufacturers do not stamp the rated capacity on the master links, because they want to make sure that the final fabricator is going to rate them according to the material that they've rigged them with. However, we use them for rigging components. We'll use them on a hook to help create rigging points for attached shackles, chain falls, come-alongs, all the other kinds of equipment we want to rig from, and we'll use them just like extended shackles. And they're great tools. It's great to have them available, slap them on a hook, and rig from there. So since they're not marked, our suggestion is to find out from the cut sheet what the capacity is for the master link and sublink and mark it accordingly. All right? So just word of the wise, mark all your hardware. Let's take a look at positive connections. Let's see, Zach. Well, okay, we've got to poll it in a little bit. So let's keep going here. Positive connections. I want you to build a little tree. If you got something to write with on a piece of paper, kind of work with me here. I'm going to go from highest and most desirable to least desirable in this about 6 frames here. And so the first frame really is, if we had our druthers, we had our choice, we would go what we're going to call is a direct connection as our most preferred method. Direct connection means I've got hard points to connect to on my load, and I don't have to choke or basket it. The minute I start choking and basketing, I've got to contact the sling to the load. If I could shackle it or hook it directly to the load by some hardware connection point, and notice what I've done here, what we did when we set this up is we double shackled right here, and the double shackle moves the sling away from a crush point or a contact point right there on that gusset. And that's an approved lifting point, but if we hadn't put that second shackle in there, that sling would have been very much involved with that gusset right there with that steel plate, and we wanted to step that away. So what we did was we added a second series of shackles to help step that up and off, and then let the sling make the connection. And even on top of that, you can notice right there, we put on some corner protectors just to make sure if the load would pendulum or do anything unusual, we had hard steel plate right on top of the load, and we wanted to make sure and not let the sling interact with that. So we just put some magnetic corner protectors right there to avoid any contact. So the first one in our decision tree is, do I have a direct connect possible load? Can I make a direct connection and avoid potential sling contact? That helps clean up everything, and it helps minimize or lower the risk. And this is all about lowering risk downstream for all of our rigging activities. So can I make a direct connection? Let's go to the next one. If I don't have those, can I create a direct connection? So I'm going to bypass those. They may not be approved lifting points. I'm going to look on the load or look at the load surface, and in this case, we've added swivel hoist strings into an approved lifting point on the plate, on the top plate, which is more than substantial to support the load. And these swivel hoist strings are rated for their pick points at this connection point. So I didn't have, so one is direct connection, and then second one is create my pick points, and that are also direct connections. So if I don't have them already naturally, can I create them by using swivel hoist strings? And if for all my friends that have been attending a number of these webinars, you know I'm a big fan of hoist strings, and there's probably a dozen different styles, types, and pedigrees of different hoist strings out there. Crosby is a manufacturer of those. CM, Rudd makes a terrific line of hoist strings, and others. But there's a lot of options. Take a look at a lot of the catalogs that your rigging supplier can provide you and start looking through what particular connector might work best for a particular load, because one won't do everything. These are through bolted and nutted off on the bottom side there. So some come thread so that you can just use them into a threaded connection point that will accept that bolt. Some are through bolted. There's a pass-through hole and then hard washer and nut off the bottom side. So in this case, we did not have a direct connection opportunity, so we went to creating our own pick points. Let's go to the next step. If I don't have either one of those, we've used this all on the same load, can I find a place or a way to create stopper points that would stop sling movement? And so we looked at the load real hard, and we said, you know, we've got a nice platform right here, and we have a wall right here. So we choked right there, and we do have the opportunity. These aren't, the load is very acceptable to the capacity of these chain legs. The chain sling's very robust, and within capacity, you have the opportunity to go around a 90-degree corner as needed right here, but you always want to check the rating and any limitations. So this case is perfectly acceptable. It is legal, but what the beauty of this is that we were able to find a place that we could slide the slings on up to a wall or stopper point so they cannot go further into the load. So we don't have any sling running. All those sling legs are going up to a master link, which go to the hook, and there's no movement anticipated because we're all up against a wall and nothing really can run on us. So I've got direct connection, create pick points, and now I've got stopper points. That's my third in my hierarchy. For those that are keeping score here, this is my third option. Let's go to the fourth option. Will a spreader bar help us take away the opportunity for the slings to run? So in this case, we've got slings that are, base material that are wrapped around the load pick points that with PSI based on sling connection points and the width of the sling, these are very suitable for resisting the sling to penetrate that material and to come up to the connection point on the spreader bar. These spreader bars, certainly this is one particular style. Another style may come up and rig up to the hook from the outboard side. This is a universal bar. You can use this and flip this over and use it for 2 crane picks, or you can use it right side up like it is now for a single crane pick. The real intent here is to see that there is basically a 90-degree angle right there, and there's really no inducement for the sling to run out or run in. I'll do that in a different color. So it's not going to run out or run in because of that 90 degrees. So sling sliding, really, we've taken that opportunity away by letting that sling come straight away off that edge or that point at 90 degrees. And we really have very little risk of sling movement while the load's being suspended. So going back to our score sheet, we've got direct connection. We created pick points. We've got a sling stopper point, and we've taken away sling sliding by 90-degree rigging using a spreader bar. All my hieroglyphics there. Okay, so let's take a look at the next one. We've gone with excessively long slings. Notice we've used chain slings up here at the top for the initial leg extensions off the hook, and then we've added double wrap baskets on each bearing point. Part of this is baskets equal greatest capacity, and that's always a good thing. So based on our vertical choker and basket options, basket give us great capacity, double wrapping give us friction control, grip. There's just a ton of words we can use for that, but it's squeezing the load and helping minimize the opportunity for sling movement. And in this case, these slings, this compound angle kind of runs towards the center of gravity right there. This angle is in the 70-degree range or better. We want to rig at or above 60, so we're at 70 here. We're in great shape. Very, very low risk of running, and we have not. What we didn't do is push those slings up against that hard wall right there. We let the gripping action of that double wrap do the securement for us as we applied the slings to the load. So no spreader bar at the top. Everything meets at the crane hook at the master link. Nice long slings, double wrap baskets, great capacity, very, very minimal risk of sling movement based on the sling protection material as well as the double wrap and nice tall angle. So there's our long legs are a big adder. Nice long slings, good sky, double wrap, and basket. That helps refine our selection list. And of course, our last one is certainly a way we want to always avoid. This is a do not do kind of application. There is a large warning sign up here, danger. Notice how that sling is just single wrap choked around the entire structure. Excellent opportunity to have, actually, when we took this photograph, we used 4 slings to create this, and we had to reject every sling. This was a hoist it, hold it, lower it, and we only held it up 2 feet off the ground, and we put it back down for the photo opportunity, and we ended up rejecting every one of these 4 slings. We thought maybe it would actually fail. Our crane was huge for capacity. We weren't really concerned about it for reaction, but I'll tell you what, we had to reject all 4 of these slings after this photo opportunity to help demonstrate the bad thing that can be done with slings. No sling protection, nothing in here to protect the slings at any of these corner points. So we had no protection. We had, not a great angle. We were probably at 60 degrees, less than or equal to 60 degrees, and we had a choker hitch, which is, it's okay to rig with, but we had the lowest capacity sling being used in that application. So, and the thin sling, narrow sling is only 1 inch wide. We had a high PSI. I mean, we just sort of keep going down the list here of all the bad things related to this. But at the end of the day, we had to reject those slings from use because of damage created by this one particular pick for this photo opportunity to help demonstrate something that was really a great thing to avoid at all costs. Okay, let's keep going. Recommendations. How do we fix some of these things? Well, first thing I'd suggest to you is when you are talking with the suppliers and vendors, work with them on trying to get fixed rigging points on your loads. So these fixed points will help a lot in avoiding sling contact to the load, and they end up at good structural lifting points. They've been reviewed by an engineer, hopefully, and their integrity is there, and it helps keep the slings away from the load. So anytime we can, let's ask for good pick points on the load. We have a pump manufacturer that we work with. They put a motor at one end, and it's all connected with couplings and housings, and a large pump is put at the other end up on a deck, and I'll just put a flute up here. And so this is how they mount this to their to the unit. They provide a flat deck with it, and normally this flat deck is actually built with small I-beam, and it is a all by itself. It goes out of it used to go out of the factory just like this, and folks were having to jerry rig this, kind of coming around the motor and trying to rig this up in almost any crazy way possible. So we convinced the manufacturer, listen, if you want to lower the risk related to your product being dropped on the first day it's delivered, let's create pick points on this load, which they ended up doing, and they welded those in right into that channel and extended the ears out and created gusseted pick points for folks to rig from. So they had 4 extended rigging points to go off of to help handling this product in the field, and these were all reinforced and secured. And so I mean, they did a great job on fixing the issue and substantially lowered the risk related to handling their pumps. So this is a good case where a manufacturer was contacted, and they responded very well in creating a better package for us to handle in the field. When you need to, in this case, it's a triple strong back, but even a single strong back or a triple spreader bar or a single spreader bar will work. I'll just draw one end, and if you all remember from our previous, you can have 4 legs coming off. They help hit that load at 90 degrees to the horizontal, to the long axis of the load. But in either case, it could be baskets. But what the spreader bar does, it takes away this angle issue. So if we draw in another set of slings that without the spreader bar, we want to come down here like this, come down here like this, we're causing that sling to try to pull in. So if we can take away the desire for the sling to run by using a spreader bar or a series of spreader bars, we will lower the risk related to our load handling activities. Notice in this photo, these guys have done a great job. They've got 2 crane picks. Here's one crane and another crane. Off this particular crane, they've got one spreader bar at the top. They feed down to smaller spreader bars right underneath, and then those slings are suspended from those baby bars. And they've done that twice, and they've spread the load out over numerous slings, 4 slings in this case, that have equalizing opportunity because of the multiple spreader bars, and a great way to handle that particular yacht. So everybody hates to drop a big yacht, and it's happened more than once from loss of control based on poor rigging methods. Let's take a look at the next one. This kind of helps when the center of gravity is below the pick points, or you've got an unusually large load. VersaBar and MaxiBar, some others have these, and Lone Star makes a series of these bars, Lone Star rigging as well. But I'll tell you what, these are a great invention. I think John Cacciatorian for VersaBar really came up with this and patented this for years ago. But just using sockets, basically end caps that are rated and based on the length of the pipe that's put in, the rating will change. The longer the pipe, the lower the rating. Shorter the pipe, the higher the rating. So we have large pipes down there at the lower section, and spreader pipes across here at the top. And that allows us, which is the end goal here, is allows us to have the slings coming vertical right off the ends of those bars at the corners for that lift. And there's no other imposed forces except vertical to the lifting lugs or trunnions. Everything's good, and the load's in good controlled shape. Now, it's a huge load, and it can be done on big loads and small loads, and I'll show you an example of that in just a few minutes. Great way to rig this up, but it really takes at least some small dollar investment. We just did a job for a longshore stevedore company for moving a large vessel off, and we used Lifting Gear Hire, LGH. Take a look at their website. You can rent all this gear for the time being, for the necessary load to be handled for a week or 2 weeks, send it back out, and but they can send you modular bars for use for a variety of applications. We're not endorsing anybody, I'm just giving you one lead there, and we will show you some other manufacturers of products in just a few minutes. But folks that do rent gear, this could be, you don't have to buy all of it. Sometimes you can rent it at a very short term, but very important to handle the load that's assigned to you. So let's look at sling protection. Let's go back one here. Here we put in a, this is called a crescent-shaped thimble. Notice that this thimble is actually kind of burying inside there, and it's actually a cast thimble that you can add on after the sling is fabricated. It's got little ear tabs on it, and it could go in the eye of a sling. I'll put the sling up here. So you can add it on to the eye of a sling after fabrication, or in this case, this is an oversized thimble that we've used in the belly of a basket hitch to go around a hard edge. So that sling, those ears have been bent over, and that's a permanent kind of basket hitch. We can roll the sling over constantly and do inspections on it freely, so the inspectability is all great. Nuco Manufacturing out of Kansas City makes those, and those are almost always available through your rigging supplier wherever you're at locally, and other manufacturers make similar products. But it's a great place to do a basket hitch, sling protector, hard, significant, robust, easy to spread that load out over a large surface and to cradle into hard pick points. So there's one way to use a thimble, an oversized thimble, to actually help protect wire rope slings, chain slings, could be web slings or round slings, to help get around some hard surfaces. Let's take a look at the next one. This one actually came from Italy, and there may be a couple of manufacturers here locally that produce these. We use them. We've got a couple of them here, but they're magnetic aluminum. They've got small magnets on the inside, but it's 2 pieces that hinge. So it's got a carrying tray or a track right in here for wire rope, and it hinges to another piece that will break around a 90-degree surface like that. So there's magnets right on the inside, and this breaks around almost any 90. Can go flat, but it's really built for corners. But they're great tools to help send a rope, and they come in different sizes for different wire ropes. So great place to insert or install a wire rope sling protection system that'll let the sling keep it from being damaged by the edge and give it a lifespan to live another day for other lifts. This one is, there's a number of manufacturers of this. This is a Corner Max, and this particular one, if you can envision, there are 3 synthetic plastic rods that are embedded in the webbing right here, and they create a wall. And they're sewn into the webbing as like a sandwich. And then there are 3 more down underneath that create a push or a wall to keep the sling off the edge. The sling can lift as much, up to rated capacity, and because of this wall created right here and right underneath, it keeps that sling material away from that edge. So these will bend at the midsection, at the midline right there, and they'll form themselves around that 90-degree corner, very much like a sheetrock a sheetrock protector used for tie downs for truck and over-the-road transportation. So it just, in the old days, we would have thrown in a wood block that would not have probably stayed in place. Thrown a big old wood block in here to help try to do the same thing. But this is really an engineered piece and do great. We own a bunch of these in our training centers and use them on a regular basis. A similar product, I'll show it to you in just a minute. This is a Dyneema pad. This is a very high strength sling protector. It's a tube, a sleeve, and it's made for edges. The main caution is you don't want it to run. I'll just put no running up here. Straightaway pulling, it's great, but you don't want it to slide or run sideways on you. But it has very high durability and cut resistant to an edge. And check with Dyneema through SlingMax and other Dyneema resellers and find out what the engineering is behind it. We have some of these on our property as well. They do work on particular applications, obviously very flexible. Let's take a look. One thing you want to do is to calculate the anticipated PSI at the corner so that we understand what that sling is going to impose onto the corner in pounds per square inch. And sometimes in the 4,000 to 8,000 pound, you can shear right through those old web slings, old fire hose, all that. It's very easy to shear that material out of the way. Old nasty conveyor belt sometimes will shear. So you want to do some calculation. How many square inches, what's the loading per square inch that I'm going to impose on the sling at the corner, and is my sling protection robust enough to withstand that? This is one I particularly like for numerous applications, and it actually uses metal mesh like we use in metal mesh slings. They take and this, I'll just draw this out quickly, but they open this piece up here and insert a piece of metal mesh material. It might be 12 inches wide, and then they'll sandwich that in. They'll close this up and sew it down, and that metal mesh is now embedded in a sandwich between some very robust synthetic protection material, and then the sling wraps around the outside of that. So the sling is laying outboard of that, and it's actually, there's steel between the sling and the load. And it's very flexible to the load if it's a 90-degree or sharper edge, maybe a more robust break edge. But it's great for, in this case, they've got a limitation. They've actually published 20,000 pound limit for that sling bearing point right there. So it's super material. It's one of the best flexible sling protectors I know of for a lot of applications where we want to hold that sling off the edge. And these stack up very well. Of course, they've got Velcro keepers that keep the sling. They lap over and keep the sling in place. But these are phenomenal, and they do a great job, and I compliment the inventor and also the resellers for making sure that they're available in the marketplace. And we would encourage you to start building your sling protection inventory. Let's go back to, this is a standard wear pad. This is the old abrasion one that was in that accident, but it's suitable for wood. Got some rounded edges there or other abrasion type things, but this is not for cut protection. So it's limited. I think that's the main thing, limited in use for rough surfaces. And that's really its forte, is to help protect against that, to help hold off abrasion. Let's take a look then at, these are, you started to see these in the marketplace. Ray Linton Rigging Products makes these, and they're magnetic synthetic corner protectors, and they will attach to the load. We can run slings around them, and they have shoulders up to keep them. It's the old system or style of corner rounds. We used to cut out a pipe, steel pipe and aluminum pipe, to help break sling edge, break around different corners. Now, but with the advent of the magnets inside, they're machined to a particular dimension, and they can come in 4-inch, 6, 8, 10, 12-inch wide pieces, and they work great. They actually, and I think the next frame shows them, they actually make them for I-beams. I'm not a big fan of rigging I-beams with synthetic slings, but in this case, with that type of sling protection, I think you'd probably be in good shape. But the main thing is that the sling's got to be able to stay in the track and go up and not be encouraged to move either direction. So with a spreader bar, that's great. Rigging up to a single point on a crane hook, that might be a challenge, because that sling may want to drift off at an angle, and if that sling protector is not in the right place, it may try to walk off of there, any sling protector. So make sure this is a great application for a spreader bar, 90-degree face loading, perpendicular to the load face. So, all right, let's take a look. And we know that the difference on these old style abrasion pads will not do the job we need, particularly with cutting and some friction damage. Zach, I think you have the last poll, and then we just have a little bit more to cover before we finish for the day. So you have another poll to give to our participants?
Yeah, I just launched it. It says, regarding sling protection, we don't use any. We have inadequate materials. We are adding better materials to our inventory. We have and use excellent sling protection materials. So it's sort of an audit of your sling protection inventory. So I'll leave the poll open for about 20 seconds or so. And I don't know if you have any comments for this, Mike, but have about half the people voted so far.
I think my comment, Zach, is we're willing to spend, to have a budget, maybe 10,000, 20, or it could be 30 or 40,000, even more, for our rigging inventory to change out every year. I know some companies in Canada and others, they have a 12-month recycle of all their synthetic sling products. They just take them all out of service. They date them as they put them in service, and they take them out after 12 months. It's a very expensive adventure, and if we would actually, if we're going to spend 20,000 or 30,000 on slings every year, particularly synthetic slings, I mean, there's a huge inventory that a lot of people have. I think if they put in a $3,000 to $5,000 worth of inventory of sling protection, like we've been describing here, they can get 2, 3, and 4 years out of their slings and substantially lower their overall cost to their rigging budget, for long term. Additional, certainly lower the risk to potential load drops and hazards associated with sling interface with hard edges and bad connection points or bad contact points. So a small investment up front will do great to extend, to save money for the company and lower the risk to the employees and to the loads being handled. Well, how did our poll come out? Let's see what we got for our results.
Yeah, we have, most people have chimed in there, so I'm going to share the results now, and it looks like almost half the folks said we are adding better materials to our inventory, and then about 34% said we don't use any or we have inadequate.
Okay.
And then 20%
right.
of the attendees said we have and use excellent sling protection.
Okay. Well, I think that's a big tip-off to all of us. Certainly in every industry, every environment, every plant, facility, or construction project, we want to I think we want to be proactive in determining what we're going to need for sling protection and not grabbing stuff at the last minute. I know I've been on a lot of construction sites where, my gosh, we'll just grab on some welder's gloves, and unfortunately they'll throw them in as hoping that that'll hold the sling off the edge and actually sever the glove, do damage to the sling, if not drop the load in some cases. So we want to be proactive, investing in that sling protection up front, and that will save us downstream for some of these unplanned events and load drops. So that helps us, and this is something I really want you to take to heart, is we really need to step up what we're doing for sling protection and start making that investment. Okay, let's take a look then at some lifting devices, and this will close us out, but these are things when shackles and slings may not just be the perfect answer. What can we use? What additional items can we use to help us in our rigging projects out there? There are beam clamps out there for use. They are limited in how they're to be applied. Quite often they are limited to vertical loading only. That would probably include a spreader bar, and it would be two of them in this case, one here and one further downstream. So they really need to be used properly. These don't do too well if we're trying to slide them, because of angular loading. So these have limited application, but when we got to grab a beam, sometimes instead of wrecking or cutting some wire rope slings, if that's the case, or certainly synthetic slings, maybe beam clamps will be a better option for us. Some are more robust in their design. Great beam clamp here. And I've tried to put in the names of some of the manufacturers that we've drawn from here just to help highlight. But Crosby Group makes these, and they do have a minimum angle requirement here of 75 degrees. That'd be 15 degrees off the vertical. And but they are rated, and they will lock in and hold the beam and not slide along the beam. So some good options for beam handling right there. This is a fun little spreader frame. Caldwell makes this. I'm sure other folks do, and believe me, we just don't have all day to go through everybody's inventory of all the manufacturers of the items that they make, but I know we've highlighted some things from Bushman, Caldwell, also Tandem Lock. We've highlighted VersaBar, MaxiBar, Lone Star Rigging. I mean, there's just a lot of folks out there that we also buy from. We do not manufacture any of these products, and we don't resell any of these products. We're in the user business just like you guys are, and so we're always out on the hunt for good equipment to help solve problems. This particular adjustable frame right here can be, what happens is you can get the pipe based on the requirements of the manufacturer. You can get pipe that will insert for the ends and for the long sides of various lengths, and as the lengths grow, of course, the capacity will drop off. But the corner connectors and hoist strings and shackles have the maximum necessary rated capacity and for the highest load condition. And then if we just spread the pipes out, get longer pipes, we may be over rigged a little bit at the corners, but the pipe is becoming our weaker member at that point, and the rating drops. But this is a great assembly, and you can actually buy this in a kit and buy the pipes necessary for it based on specifications. But they've got these from 6 to 9 tons spread up from, I think it's down to like a 4x6, and can be expanded up to a 12x12 based on this particular type of assembly. Chain slings, the top side rigging may be permanent in nature, and then we just change out pipes to help accommodate what we have, and also that accommodates for headroom available. So great kind of universal assembly, can be used in a lot of manufacturing or a lot of other areas that have adjustable requirements, that you have various loads of various sizes and various weights. So pretty high capacity actually for what we need. So nice option. You ought to take a look at it. This also is made by Caldwell. This is a rig release, and for setting trusses in construction, or where you can't get immediate access to release the rigging. This has a pull rope or radio remote control for release, and will not release under tension. So it has to be completely slack to disengage. There's a load pin right in here that holds the sling in place, and then once you pull that load pin by pulling the trigger with no tension on it, you're good to go. I think I actually have a picture of this where they're Christmas treeing and able to actually rig there's one, there's two, there's three, and there's another down below. But this is Christmas treeing multiple beams up for high use, high efficient rigging. And so of course then each beam would be rigged off of this, and the beam would be down here. And so once you get the beam set, you pull the trigger, that slings simply drop out of that and stay connected to the load in the appropriate manner. So a great tool, good for access from the ground or radio remote. The guy doesn't have to be right in the basket right there to help cut the rigging away after we've set some trusses or some beams. Here's another one. This came, had an accident came about. We've had this numerous times. People rigging pallets with all kinds of materials up on top of a pallet being put up for construction. And the slings have been rigged through the fork pockets back up. And as most all of us know, these things crush, collapse. All this goes away, and we dump the load out. So avoid at all costs rigging pallets if you can. This is a great tool to do that, and many people make devices like this. This bail can be adjustable forward and back to help get over the center of gravity. You always want to rig to the CG. So wherever the center of gravity is for the load, an item that's being handled here, you want to make sure that we've got it captured, and that really needs to be right in line with our pick point. And then the forks pockets, easily suitable to handle the pallet. That's maybe the carrying tray for this item, and that can be put up onto the building top or wherever the upper elevation is that we're having to take the load. So fork lifters, pallet forks are great for handling loads. One thing I'd encourage you to do for safety directors and other folks that are with us on the line here, make sure that this material stays plasticized or wrapped. Don't move loose bundles of anything up, like a bundle of bricks or any other sheet items. Make sure it stays bundled, stays wrapped until it's landed into location. Never send anything up that's actually, somebody thinks they're doing you a good favor by cutting the banding away or doing that at ground level. Well, the worst thing you can do is cut it away at ground level, and we really need it to stay as a unitized load before it gets up to landing. So make sure it stays as a solid object. Here's a nice little adjustable spreader bar. A lot of people make these. Notice the pinholes right here. You can expand or retract the spreader, and the slings accommodate to the worst load angle, and they're rated for that. Sling hooks are rated for the beam that's connected to it as well as the master link. So we could retract this to, say, 4 feet, expand it to 8 feet, particularly maybe, or 6 feet in this configuration. They do sell, I noticed that Caldwell sells a couple of spreader bar lines, adjustable ones that go from 4 to 20 feet, anywhere from 2 ton to 15 ton. The shorter the bar is, typically the higher capacity. So these are available, and the reason we want these adjustabilities so we can use them for various loads in our facilities. We don't have to buy 16 spreader bars to do the job that 2 or 3 could do. So let's see, we've got, this is the end caps that you saw in the photograph with the yacht, and based on the length of pipe, scheduled pipe diameter, we have various capacities. And some of these start with tandem lock at 14 tons and above, and can go to 100 ton, 200 ton, and higher based on what you're needing. So the end caps are the rated items. They give you the specific pipes to purchase based on wall thickness, length, and steel type, and so on, that will create the capacity that we need. So spreader bar kits are available from a variety of vendors and suppliers. Here's a unique little lifter by Bushman. It's a counterweighted spreader bar or lifting beam, and this counterweighted weight out here will trolley in and out based on the load's position. So as the load is, when the load's just before it's picked up, this is trolleyed forward and basically at the center of the bar. And as you accept load, this can be trolleyed out to its most extreme stopping point out here to counteract the weight of the load that's being suspended. You can put a load in through a wall on a building, set the load down, and then trolley forward our counterweight as it goes to 0 for load weight. So a great tool to help set a load into an enclosure or a third-story, fourth-story barn door, or side opening in a wall in a building to help land loads up there from the outside. All kinds of unique tools out there and things that can be helpful for us to get loads in place. And these are all manufactured and kind of off the shelf and or unique and quickly available based on your call. Of course, tilt-up rigging, spreader bars, rolling blocks to help turn loads. Use the right tool for the right job. And for this kind of work, these are everyday tools for these guys. But we wouldn't want to start substituting rigging in there to help hopefully do the job necessary. This rolling block is really helping multiple blocks to help spread the load across the surface of those panels. Make sure we don't break it, crack it, fracture it, or overstress it. And rolling blocks really do the job. So right tools, right job, help get the job done in a controlled manner. Obviously, this is a direct connection load. The slings do run through blocks and have a tailing opportunity, or we use the floor for tailing. So great system, but that's really using the proper tools for the right application. Okay, we've run through a considerable amount of information, and we're to the end of our activities right here, and we have some questions and answers. Zach, I'm not sure if we've had any questions come in during the presentation, but let me know and see what we can do to help answer them.
Yeah, we certainly did. Martin asked, can we get the formula for PSI on a sling?
Well, at the base, at the end of the day, I'll just share with you how we might do this. Let's take sort of the simplest approach first, and that might be a spreader bar. And we're going to rig up like this, and we're going to come down and basket to 4 points like this. And we've got some adjustability. Slings are good for length, and we're going to basket to 4 bearing points. And I'll redo that one there. It's just, that's ugly. Okay. So our load surface, our load structure sitting in here, and we've got four legs going through, and we're all rigged out. So if I know I've got 10,000 pounds in this sling leg with basically what I've done is taken the corner load, and I'm going to, at this point, based on the spreader bar and its hingeability and so on, I'm going to assume I've got 10,000 at that bearing point, which includes the angle. So the real load might be 8,500 pounds, let's say, and I've accounted for additional tension based on the angle. So now I've got 10,000 pounds for that sling, making that contact right there. 10,000 pounds for the sling as it wraps around. Let's say it's a 2-inch sling. It's 2 inches wide. So it's 2 inches wide. I've got 10,000 pounds of load at that bearing point. And just for simplistic reasons, we're going to take the 10,000, divide it by my 2 inches of surface, and I've got 5,000 pounds of pressure for each inch of width. So I got 2 inches right there. So I've got 5,000 here and 5,000 here on that 1 inch on each inch of width of that 2-inch sling. I know that's really simplified, but it gets you very close. You have to always account for the angle and the horizontal force that adds to the tension. But that's what that sling's feeling. If you put your fingers right in there and right in between the sling and the load, and we want to sever those off, it happened in a heartbeat. That's like if you think about it, if we turned all this upside down, that's like putting a full pickup truck bearing pressure right here on that 1 inch of sling material. That's 5,000 pounds of push there and another 5,000 pounds of push right here from an external press or source. And that's what that sling's feeling as it presses into the corner of the load. So the material we put in there, if it's a little cheap old conveyor belting that 1/4 inch thick or 1/8 inch thick, it might be gasket material. That'll sever that in a heartbeat if we have any kind of edge at all. And that 5,000 pounds of inch per width will part that, and then the sling gets to that edge, and now we've got a major problem. So that's the quickest way I can tell you. How do I figure PSI for a sling contact point? Take base load, take my angle, which adds additional force. What's the width of the material? Take 10,000 divided by 2 is 5,000 per inch of width. And that's a quick way to estimate the approximate force at that contact point between sling and load. I appreciate the question very much. Let's see if there's another question.
Yeah, there's several here. I'm going to weed through a couple of them. But one really good question I think is came up at the end with Brian. What is the general life of a synthetic sling with proper storage and care?
Good question. There is no shelf life for synthetic slings. They've gone through 10-year tests and really determined that, hey, if you take good care of them, if they're good on the day they're born and they've got rated capacity and good breaking strength, they've been fabricated properly, shelf life's not an issue. I've seen slings easily go from 7 to 12 years in powerhouses and power plants. They don't get a lot of use, but they might be larger capacity slings that get used 20, 30 times a year, and it's nothing to get 7 to 10 to 12 years out of a sling, web sling. So really years, you know, I think I don't think I've ever done this for slings, but you know, what's the lift count? That has some, the number of lifts for a sling is not a big deal, but it's how well protected do we create the setting point for the sling to the load. So lift count really isn't an issue. I don't think that's, whether it's 100 times or 1,000 times, that's not really what I'd be concerned about. It's all about direct contact. And that's what's going to take the life away from a sling. How many times does that sling directly contact the load surface as it lifts? Because as we know, synthetic web slings, as they take tension, they are stretching and elongating. And they might elongate 3 to 5 to 7% as they take tension. That elongation against the load surface by itself is going to create, even for maybe a shaft or other steel objects, that's going to create some abrasion. And so you do that 1,000 times, and we're going to have an abraded surface. I mean, it's just going to happen. And the more harsh the surface contact is, that abrasion is going to turn into possible small cuts and so on. So I'd say really it's all about how many times is it sling directly contacting the load. And there's no magic formula. Certainly some edges are going to be more harsh than others. Do we have sling protection in place? It's most construction projects, the guys I work with Walsh and Anderson and a number of other, if they can get 3 months out of synthetic slings on their project, they're happy campers. So they're heavily abused. They don't use a lot of sling protection, and if they get a year, you know, they're really a hero because they take a lot of abuse just from normally scrubbing up against or stretching and elongating against the load surface, and it's going to cause some natural abrasion, possibly a little bit of friction, but some natural skinning of the outer material, and just eventually, you know, any abrasion, you know, that's recognizable, nicks, cuts, tears, snags, punctures, all those are really an issue for those slings. So, in normal applications, if you can get a year's worth out of your slings, you're doing pretty good. It means you're using sling protection or direct connection methods. The only other thing, Zach, that I would add to that is ultraviolet ray degradation. And I think I've shown this a couple of times on our webinars, but at 100% breaking strength, 50% breaking strength down to 0, and down across the bottom, this is months. So at 0 months, 6, 12, 18, and 24, the average life drop-off based on reasonably regular use, you know, maybe 100+ days a year exposed to UV and sunlight, the breakdown of that material can be very significant very quickly. And it's typically sort of in this in this line. And so ultraviolet ray starts to take away muscle from the sling, starts to burn the fibers, and from the first day it starts to get exposed, it starts to deteriorate that sling. And so for slings that are used outside, I'd say the lifespan really, my goodness, at the 3-month window, you're right there. You know, we've lost maybe 25% of the sling if it's on a regular daily basis used out in the sunlight. So sunlight is a different cause for breakdown for the sling versus the abrasion and things we talked about a minute ago. But goodness, at 6 months, we're at half the sling use, or sling strength. We're way past where we should be rejecting it. We need to be rejecting that sling up here in this range when we can determine and identify. We're going to see discoloration. We're going to see a fuzzy surface to the sling. Where it used to be slick and oily, it's going to be cottony and fuzzy because the fibers are starting to burn to the outside and stand up and create small hairs to the surface like a cotton. And so when we start discoloration and a fuzzy surface, we know we've got breakdown. We need to reject the sling because of UV degradation. And we might not even be to the 3-month window on daily, regular, long day use. So that's a whole different animal than the abrasion or cutting or snags or punctures, but it's something that's very real, and it really steals strength faster than anyone's ever really accounted for before. And there's been 2 really good tests done by AWRF, Associated Wire Rope Fabricators, on breakdown of synthetic materials. They've done a marvelous job to help protect us in the field about the effects of sunlight and welding exposure to synthetic slings. Great question. I appreciate that. I hope I've got some good answers for you out of that.
All right. Awesome.
Go ahead with the next one.
There's a good question on sling protection. Why do you recommend against using fire hose to protect sharp corners? Are there any acceptable applications for using fire hose to protect slings?
I'm gonna suggest to you that fire hose is really restricted to abrasion only, and there's no good shear strength in fire hose, and that's really the secret. And it's all about PSI. It's all about what that load corner is going to induce and push into and shear that fire hose. So it's really, the big answer really is fire hose, abrasion only. That's really the deal. It can certainly serve in that role if abrasion is the issue. But when it goes to a corner, it just doesn't have the robustness, thickness, and durability and constitution to withstand the pressure created by the sling pushing into the load edge as it starts to lift. And it can shear it in a heartbeat, and the sling's now bare naked against the edge of the load, and we can cut the sling, drop the load. So there's my take on fire hose, limited application, abrasion only.
Okay, excellent. Well, I think that about does it for the questions. There's several similar questions to those regarding rubber pads, for instance, for sling protection. I think you just kind of answered it.
Same answer, yeah. Same answer.
Yeah.
Go ahead.
Steve asked, do you have pre-job briefs available for any of these incidents? I'm not sure if you do.
In most cases, in the accidents, maybe, is that the kind of the question direction?
Yeah.
Or?
Yes.
Yeah. Really, I can tell you that of the 6 accidents that we evaluated, there were in some cases there were a few pre-lift meetings, and if I can recall correctly, 3 out of the 6 at least had a pre-lift meeting, but each missed the sling protection issue and a little bit on the rigging calculation. And so really at the end of the day, even though a pre-job meeting, pre-lift meeting occurred in half the cases, they really missed the step on, yes, we have the right slings, yes, we have the right capacity, well, we're good to go, we got the load controlled, that's the assumption. What's the next question? So they kind of breezed through that, but what they really missed was the sling protected to do the job. and that was the biggest downfall in most of these cases that we've evaluated. That's a great question. And so just don't take it to heart that, gee, just because we did a pre-lift meeting, we're all locked and loaded and everything's perfect. That is a grossly wrong assumption. We want to make sure that we've got everything protected and secured as needed. Great question.
Okay, one other came in, and Jim Worrell actually asked a good question, but you were talking about the bump fender, or sorry, the pump I think it was when you were referring to one of our customers. Did your pump customer take into account with the lifting lugs on the skid units the center of gravity? Most skid unit fabricators do not do this.
Yes, a good question. Yes. So as we add, no, that's a great question. As we add pick points like that, they've got to be robust enough. What we really worked with, and this is a great question, but the orientation of the lifting points, ideally, so we'll just do a top view of this thing, but the orientation really ideally is towards the center of gravity. That would be one thing that we'd first encourage a client to think about, that it needs to be, the strength of that lifting lug needs to be 90 degrees and the plate pulling to the CG so that it's welded in the right orientation, supported properly, and so on. Another element is that, kind of an advisement is, and this is a little bit of a long-winded approach to this, but we encourage folks to take a look at so that two legs can support the whole load. And so that if the slings that are attached in the field or the factory, if it's only loaded really heavily on these two corners out of the four, can the design of the pad eye be able to sustain two legs taking the whole load at 30 degrees, very flat? So that's a rigging angle issue. So now they need to be more robust yet, and and typically we're going to endorse the idea that they need to be a minimum, just from a rigging principle standpoint. This sounds kind of crazy, but a minimum of 4-to-1 design factor. You could go 3. Going 5's good, but it's not. It's probably a little over designed at that point, and there would be a ton of arguments about, well, what design factor should we go to? But I think 4-to-1 is suitable for that, and for those applications. Chain slings aren't any more than 4-to-1. But what we've done is required, instead of creating a lightweight design where a design engineer might think he can get 4-corner loading, which is not very realistic, he's going to design it so that 2 can carry the load, even at 30 degrees, even at 4-to-1. So when you add all those things together, you've probably done a pretty good job on your defense for that pick point and for those rigging points. And that will, and in answer to Jim's question, that will help resolve a lot of issues related to CG. Not perfectly, but when you build up those pick points to that level, your center of gravity you might be off 5%, 10%, or 15% based on where the pump's setting, where the motor's setting, and all that. If you know the pump's going to sit to one end, and we're going to have a very definite, you might even have a definite 80-20 split, well, certainly we're going to have to design to that. But for a standard package, we're going to initially try to design where's it going to be the final resting point for the center of gravity and its total load configuration, and then design to that for distribution of weight in all directions. So, and that would be in its heaviest point, in a fully loaded status. So, but we start with some preamble items that help us get there, and certainly focused to the center of gravity as our in a finished package heaviest weight condition. Excellent observation, Jim. Great comment, and that's a good focal point for folks when they're starting to make their decisions. anytime it's not loaded fully or partially loaded or just handled as a flat deck, all these other parameters will cover you. But once we get fully loaded and have a pre-prescribed center of gravity position, then all things need to be accounted for in that final evaluation or analysis. Excellent question, Jim. I appreciate it very much. Go ahead, Zach.
Yeah, this will be the last one. One more question came in, and we're just running out of time, but it was basically May is looking for comments regarding chemical corrosion applications in acids and caustics immersion. So it sounds like they're dipping product. Also,
yep.
Environment that has heat, a lot of heat or ambient. It's kind of a
yep.
parceled out question. And then chemical compatibility and temperature factors. So
yep.
all those things involved regarding synthetic web slings and rope slings.
Okay. I'm not always popular, but I'm always going to give you the straight shot. And I'm going to tell you right now, with chemicals, corrosion, chemical particularly, and heat, I just think synthetic products are not anywhere close to the solution. So I think we need to avoid synthetics like the plague for those applications. And we need to stick with the steel family. And the steel family in this particular situation, I would go one of two ways. And metal mesh slings made by Liftall and others, but metal mesh slings are designed, they have, of course, a triangular end connector, and they're made for dipping and high heat and corrosion, corrosive environments like that. And some are made to pass through, so some have a slot for choking, and some are just for basketing off a spreader bar. And you use two of them, of course, for that process. But metal mesh slings would probably be my first consideration because they're very flexible. Some can be made out of product that's not carbon steel so that they'll last longer in a highly corrosive environment or chemical reactive environment. I know that in some weird applications, folks will allow stainless material to be used, but specific by that manufacturer with a rated load specific to it and specific instructions for inspection. So metal mesh would be my first choice, and my second choice would be alloy chain slings. I've worked with a couple of companies, manufacturers that have allowed I know it sounds weird, but even a grade 3 or grade 4 material, which is more robust to the corrosion or chemicals being used, or sometimes a stainless, which is a very, it's just that sling is unique to that manufacturer and it's only used for that particular application. It's not a general purpose sling. It will never be allowed outside of that dipping area for any other use. I would not be using synthetic slings. I would use one of these two steel type slings, metal mesh or alloy chain slings. I would be describing my application to my rigging vendor, and he hopefully should be pointing you to one of these two solutions first as the best, because these also deal with heat way better than, the maximum heat for a synthetic sling is more or less 180 degrees Fahrenheit. So all the way over here, we're looking at anywhere in the 400 degree range up to 1,000 or 900 degree range or so. So heat is just not an issue, not a big issue for standard applications for metal or mesh or chain, but certainly an issue for synthetic rigging. So any of those three conditions, I'd be running away very fast from introducing any of these conditions for synthetic products. I'd always be looking for a steel product to serve. Wire rope doesn't really get you there, and it doesn't have as good a heat range. Doesn't have the flexibility. So metal mesh and alloy chain probably would be our better bets. And if they have a hard time getting a rigging vendor or supplier, give us a call. We'll find where they're at, and we can point them to 2 or 3 suppliers in their areas that can provide those products.
All right. Perfect. Well, those are great answers, and I'm sure they will appreciate it. We still have about 60 folks on the line, but we're out of time. It's been 2 hours, and everyone, we really appreciate you coming on board. And again, you can get the recording won't be up for a couple days, but you'll be able to get this presentation file at iti.com/showcase, just how I showed you in the beginning. So make sure you go download it, spread the word. This is all about safe use and safe rigging use. And I just really, that's why I think these are just awesome. We're spreading the word and trying to improve the industry and improve end users' ability. So that's what ITI is about. And if we can help your organization with advanced training and anything, critical lift planning, advanced rigging, inspection, you name it, just give us a call, and we'd be happy to help. So, Mike, any last words before we go?
No, I really just appreciate everybody participating. We really enjoy our time together. This is sort of like an old home week, and we have a lot of new friends that have joined us today for the first time. I hope you find a good reason to help to join us in future webinars. And thanks so much for participating. And thank you, Zach, for helping moderate. And we look forward to some of the other showcase webinars with Joe Collins and with Jim Worrell, Jim Yates, and a number of other industry experts to help us out. And just a fun time. And these are great learning sessions for all of us. So thanks for helping put this together, Zach. We'll talk to everybody soon, and we hope you have a great weekend.
All right. Thanks, everybody. Have a good weekend.